The world is shifting faster than expected. New breakthroughs are rewriting global technological dominance. A silent revolution is rising inside China. A revolution challenging decades of Western innovation. A revolution reshaping the future of powerful computation. Today's story begins with an unexpected revelation. A revelation that stunned experts across global industries. A revelation signaling the start of a new era. 3 weeks ago, everything changed dramatically. A statement echoed across worldwide technology communities. A statement powerful enough to shake giants. A statement boldly claiming America is falling behind. This claim wasn't made by random commentators. It came from a legendary industry pioneer. A pioneer who built trillion-dollar GPU empires. A pioneer who understands computing better than anyone. His message shocked policymakers and engineers everywhere. He said China would absolutely win. Not maybe win, but definitely win. This wasn't speculation or political theater. This was a warning grounded in evidence. Evidence showing China building entirely new architecture. Evidence showing the West falling dangerously behind. While Washington argued about sanctions and chips, China solved problems once considered impossible. Problems abandoned by Western scientists decades ago. Problems experts believed had no workable solution. Yet Chinese researchers refused to stop exploring. They pushed boundaries others thought were absolute. They built something no one expected to see. They revived an old idea with stunning precision. They revived analog computing with revolutionary enhancements. Analog computing was once humanity's first path. A path natural to how reality behaves. A path using continuous signals, not digits. But early analog systems failed dramatically often. Noise corrupted signals and destroyed important calculations. Imprecision made results too unreliable for applications. Digital computing triumphed because it was stable. And for 100 years, nothing changed. Then a breakthrough rewrote everything overnight. Chinese researchers produced accuracy previously unimaginable. Accuracy surpassing digital computing in several metrics. Speed exceeding GPUs by staggering performance leaps. Efficiency approaching levels considered physically unachievable before. This wasn't minor progress or incremental innovation. This was an earthquake inside global computation landscapes. Their new analog chip computes inside memory. Data no longer travels between separate components. The bottleneck limiting digital systems disappears instantly. Calculations occur exactly where data rests. Everything happens simultaneously inside interconnected memory arrays. Parallel operations produce breathtaking performance advancements. Resistance levels replace simple binary switching entirely. Each cell holds multiple precisely tuned states. Each state allows more efficient mathematical modeling. This architecture transforms how algorithms are executed. Massive matrix operations become incredibly easier now. These operations power deep learning and inference. They support training across enormous neural networks. They define the foundation behind modern artificial intelligence. And this chip handles them with extraordinary ease. Early benchmarks revealed unbelievable performance gains. Throughput reached levels impossible for digital systems. Energy consumption dropped by orders of magnitude. Precision matched advanced fixed-point digital hardware. And all of it used older manufacturing techniques. Techniques unaffected by any Western restrictions today. China effectively sidestepped every global sanction, not by copying Western architecture or designs, not by stealing American semiconductor technologies illegally, but by creating something entirely new instead. Something the West never fully attempted before. Something capable of transforming geopolitical balances permanently. This single invention changes everything about AI. It changes computation speed across major industries. It changes how nations build technological supremacy. It changes the next chapter in global power. China now holds a decisive advantage technologically, an advantage built through determination and bold experimentation. An advantage signaling a dramatic shift forward. The real disruption begins with architecture. Digital processors separate memory from computation units. Every calculation requires constant data movement cycles. These cycles waste energy and slow performance. They create delays limiting advanced AI systems. This is called the classic computing bottleneck. A bottleneck restricting progress for decades already. China's new analog design breaks this limitation. It merges memory directly with computational function. Information stays exactly where processing occurs. No transfers, no waste, no unnecessary steps. The result is astonishing computational acceleration. Tasks that once required massive energy now don't. Tasks demanding huge GPU clusters shrink dramatically. Analog memory cells operate using resistance variability. Each cell behaves like a controllable dimmer. It stores hundreds of finely tuned resistance states. These states represent mathematical values smoothly and precisely. When current flows across these interconnected networks, parallel operations occur instantly across entire arrays. This produces extraordinary throughput at minimal power. Researchers measured 5 orders of magnitude improvement. That means a 100,000-fold precision increase. This milestone was previously considered physically impossible. It elevates analog computing beyond digital boundaries. When tested on matrix equation-solving tasks, the chip delivered 1,000 times more throughput. It consumed 100 times less electrical energy. It reached accuracy rivaling high-end digital systems, and it required no advanced semiconductor manufacturing tools. This technology isn't theoretical or experimental anymore. It isn't trapped inside academic research facilities. It isn't dependent on restricted American equipment. It was produced using commercial manufacturing technologies already. Factories can scale this technology immediately if needed. This is why analysts fear dramatic shifts. This chip bypasses global semiconductor choke points. It undermines Western control over computing hardware. It gives China independence from GPU restrictions. It launches a new paradigm beyond digital architectures. Sanctions were meant to slow China down. Instead, they accelerated domestic innovation significantly. Companies previously dependent on foreign hardware adapted. They built unique systems tailored to national needs. They received major funding to push boundaries further. Innovation intensified instead of collapsing under pressure. History proves this pattern again and again. Restricting technology fuels breakthroughs in unexpected directions. China responded by exploring unexplored architectures aggressively. They developed alternative systems rejecting Western assumptions entirely. Their analog chip embodies this new mindset boldly. This shift is already visible in multiple sectors. Telecommunications companies anticipate enormous performance benefits. Signal processing demands huge matrix calculations continuously. Digital processors struggle handling this immense workload. The new analog model performs these tasks effortlessly. In next-generation wireless environments like 6G infrastructure, Massive antenna arrays require real-time mathematical interpretation. Traditional hardware cannot sustain required speeds efficiently. Analog in-memory computing solves this problem cleanly. It performs real-time processing at tiny power levels. This unlocks 6G systems previously considered impractical globally. AI training stands to benefit even more. Training enormous language models requires colossal computation. Every parameter involves countless matrix multiplications repeatedly. These operations consume vast energy using digital circuitry. Analog cells handle these operations naturally and efficiently. Training times shrink dramatically through parallel resistance computing. Imagine training frontier models within several days. Imagine scaling enormous architectures with minimal electricity. Imagine research expanding free from energy constraints. This is the potential behind analog advancements. Edge computing becomes the next frontier opened. Tiny devices gain enormous computational capability instantly. Smartphones can run advanced AI locally now. Vehicles can process complex decisions independently on board. Medical wearables can interpret patient signals continuously. Drones can operate autonomously without cloud support. All this becomes possible through ultra-efficient analog chips. China already plans mass deployment strategies nationwide. Companies developing photonic chips demonstrate parallel trajectories. They already manufacture thousands of wafers annually domestically. Analog computing follows the same future pathway clearly. Production is feasible, scalable, and economically efficient. Energy economics gives China another massive advantage. AI demands enormous electricity worldwide without exception. Data centers strain power grids catastrophically in countries. Energy costs rise sharply across Western economies. This creates an unsustainable foundation for advanced AI. China counters this with aggressive power subsidies. Tech companies receive electricity at drastically reduced prices. Infrastructure grows specifically for computational workloads nationally, and analog computing multiplies this advantage dramatically. Lower power chips align perfectly with subsidized energy. Tomorrow's AI may require minimal electricity consumption. China positions itself perfectly for that landscape. The rest of the world struggles to adjust. The deeper implications are only beginning now. This breakthrough transforms global technological strategies permanently. Nations depend on computational power for dominance. AI's strength shapes military, economic, and scientific influence, and the country controlling efficient computation leads everything. China understands this reality exceptionally well today. They're not merely building faster processors anymore. They're building an ecosystem impossible to sanction. An ecosystem independent from Western semiconductor pipelines. An ecosystem pushing computing far beyond digital limitations. Western companies still follow predictable upgrade cycles. More transistors, larger die sizes, higher wattage. These limits create diminishing returns every new year. Digital hardware consumes enormous energy for small improvements. The ceiling is visible, and performance hits walls. Meanwhile, China explores entirely new computational directions. They challenge assumptions Western engineers stopped questioning. They rebuild architectures from foundations previously considered obsolete, and their approach keeps producing disruptive breakthroughs consistently. This analog chip is only the beginning. Researchers already outlining next-generation designs publicly. They plan larger, more integrated analog arrays. They aim for improved resistance calibration techniques. They target enhanced precision far beyond current benchmarks. Integrated circuits will combine analog, memory, and control. Full-stack computing platforms will emerge from this architecture. Telecommunications, national research labs, and AI companies prepare. This creates a serious strategic dilemma globally. How quickly can Western companies respond effectively? How deeply are they willing to rethink computing? How prepared are they to abandon digital dominance? Right now, the answer seems painfully clear. The West isn't exploring radical architectures seriously. They aren't investing in analog computing meaningfully yet. They aren't pursuing photonic systems at large scales. They aren't building alternatives beyond classical digital logic. They rely heavily on traditional semiconductor progress cycles. NVIDIA scales GPUs with enormous energy requirements. Intel struggles maintaining advanced manufacturing competitiveness continually. AMD innovates strongly, but stays within digital frameworks. Every major company reinforces the same architectural direction, a direction reaching thermal, physical, and energy boundaries. China breaks away entirely from this trajectory. They design chips needing no 3-nanometer processes. They require no advanced EUV lithography machines. They rely on older, widely available manufacturing equipment. This removes dependency on restricted foreign semiconductor technology. It neutralizes the geopolitical leverage sanctions previously offered. When a nation no longer fears supply chains, their innovation accelerates without external constraints. That's exactly what's happening inside China now. Their computing roadmap is accelerating independently and quickly. Western analysts didn't anticipate this dramatic divergence. They believed sanctions would weaken Chinese AI capabilities. Instead, China innovated outside the digital framework completely. They unlocked architectures impossible to sanction or block. The geopolitical landscape shifts every time breakthroughs emerge. This isn't just a technological transformation unfolding. It's a philosophical transformation about computing's purpose. The West optimizes current systems for marginal improvement. China reinvents systems to surpass fundamental limitations. This leads to a widening technological distance rapidly. Analog and photonic architectures become future cornerstones. Digital-only strategies risk becoming legacy approaches soon. China's manufacturing pipeline is ready for expansion, companies already scaling alternative chip designs aggressively. Industrial partners exploring integration for commercial systems. Telecom networks preparing analog accelerated signal processors. AI training labs planning domain-specific analog platforms. Research organizations adapting computational techniques accordingly. What emerges is a complete technological ecosystem. Hardware, software, energy policy, and national strategy align. Every layer amplifies the impact of analog computing. This foundation challenges Western dominance at its core. No country has ever held such combined advantages. Energy subsidies reduce operational costs significantly nationwide. New architectures reduce computational energy consumption drastically. Domestic manufacturing avoids foreign dependencies altogether. Strategic planning integrates research, industry, and infrastructure. This is a powerful, multi-layered national strategy unfolding. A strategy positioning China at future technological centers. A strategy redefining global AI competition permanently. And this is only the midpoint of transformation. The next decade will determine global leadership. It will show which nations adapt quickly enough. It will reveal who controls computing's future path. It will expose which systems belong to tomorrow. The final chapter of this shift is emerging. A chapter defining the future of computation globally. A chapter marking the end of one era. A chapter opening the beginning of another entirely. The GPU age shaped everything we know. It powered breakthroughs across science and industry. It transformed machine learning into global infrastructure. But its limits are becoming impossible to ignore. Digital systems consume massive electrical resources constantly. They require advanced fabrication tools increasingly difficult to obtain. They depend on foreign supply chains vulnerable to disruption. They scale slower as transistor physics reach boundaries. Every improvement demands larger chips and higher wattage. This model cannot support exponential AI growth long-term. Analog computing rewrites those limitations completely. It delivers performance using minimal electrical energy. It uses older manufacturing processes widely accessible globally. It performs matrix operations with natural physical properties. It accelerates AI without relying on expensive hardware. It breaks free from decades of digital bottlenecks entirely. This is why China now leads decisively. They embraced architectures others ignored or dismissed prematurely. They invested in challenging ideas requiring unconventional thinking. They solved problems believed unsolvable for generations. Their achievements redefine the landscape of global innovation. Western companies must reconsider their assumptions urgently. The future will not be won incrementally anymore. It will be won through architectural reinvention decisively. It will be won by embracing radically new paradigms. It will be won by breaking away from tradition. China already accelerates into this new computational frontier. Their research institutes coordinate directly with major industries. Their manufacturing companies prepare scalable production roadmaps. Their national energy policies support large-scale computation cheaply. Their universities produce groundbreaking work consistently and rapidly. Their engineers push computing beyond digital limitations relentlessly. This coordination creates unstoppable momentum domestically. Momentum shifting leadership toward entirely new foundations. Momentum redefining the global balance of technological power. Countries dependent on traditional GPUs face growing disadvantages. Energy costs rise sharply in Western regions annually. Infrastructure struggles to support expanding AI workloads. Data centers strain national power grids everywhere. Regulations slow innovation in several critical areas. These challenges limit growth, while China accelerates further. Analog computing changes the stakes permanently now. It favors nations with strategic long-term planning. It rewards countries investing deeply in experimentation. It elevates systems optimized for efficiency and scale. It reshapes which countries become AI superpowers globally. The next decade may bring dramatic transformations. New industries will form around analog architectures rapidly. Existing companies will adapt or fall behind aggressively. Countries will compete for leadership in unprecedented ways. The shift will define future global influence entirely. China's invention sends a powerful message worldwide. Innovation thrives where boundaries aren't accepted passively. Breakthroughs emerge when systems challenge established ideas. Progress accelerates when nations commit fully. This analog achievement represents that philosophy clearly. The question remaining is deeply important now. Will the rest of the world adapt quickly? Will Western leaders understand the shifting landscape? Will companies rethink decades-old digital assumptions? Or will they cling to architectures nearing exhaustion? History remembers nations that reinvent technology boldly. History forgets those who resist meaningful change. This moment may become a defining historical example. A new computing age has officially begun. An age powered by efficiency over raw consumption. An age built on architectures beyond digital boundaries. An age led by countries embracing radical reinvention. An age where China currently holds clear advantage. The world is entering unfamiliar territory rapidly. The competition is accelerating faster than expected. The stakes are higher than ever before, and the outcome will reshape global power structures. The future of AI will belong to innovators. It will belong to nations adapting new paradigms. It will belong to those who rethink computing entirely. And that future is already unfolding before us. This is the dawn of a new technological era, and its first chapter has only just begun.